Welcome to the Wilczewski stoichiometry lessons. This is section 8, the Alka Seltzer Lab. Okay, so if you read the ingredients on a box of Alka Seltzer, you could see it lists several different ingredients. And the way Alka Seltzer works is it's an antacid, so there's a reaction that occurs that helps dissolve acid in the stomach. So the question here is, what is the actual mass of sodium bicarbonate in each tablet? All right, so the instructions, the sodium bicarbonate here is this item. The box says it's 1,916 milligrams, but the question here is, can you prove it? If you imagine you were working for the FDA and your job was to determine if this company was honest in their labeling, so it was your job to design an experiment to prove that the sodium bicarbonate, the NaHCO3, was in fact 1,916 milligrams in each tablet. Okay, so there's the reaction. The sodium hydrogen carbonate here reacts with an acetic acid here and produces sodium acetate and water and carbon dioxide. So your objective here is to determine an experiment, a procedure, to see if in fact it's correct. So stop the tape right now and think about how you would do that. When you have an idea of how you might be able to test this, of course using stoichiometry, then come back. Okay, so hopefully you thought about this, that you can't just weigh the tablet because there's other stuff inside the tablet. So that's not going to give you the right numbers. And you could react the acid, the bicarbonate, with an acid, and according to this equation, produce water, sodium acetate, and carbon dioxide. And according to stoichiometry, if you knew the quantity of any of these things, the mass, the volume, number of particles, then you could calculate the mass of the sodium hydrogen carbonate that reacted. So if you took an Alka Seltzer and you put it in the acetic acid and reacted it, how could you know the mass of anything? Here's a procedure to get you started. You measure the mass of the tablet, pour some vinegar, acetic acid in a cup, find the total mass of the tablet and the cup with the vinegar, then place the tablet into the vinegar, stir to ensure the reaction is complete, then find the mass of the mixture after the reaction, and then use stoichiometry to calculate the mass of the... Oh, no, well, not stoichiometry, just use math to calculate the mass of the carbon dioxide. Now here's a video of the reaction of the lab. I want you to watch this video. There's no sound here, so just the lab itself. That's a Alka Seltzer tablet we put on the balance. Might want to write that number down somewhere. By the way, I'm going to do something you should never do in lab. You should never pour a liquid over a balance. If you spill it, it goes into the balance, and then you bought yourself a broken balance. Not good. So that was the acetic acid we added to the cup. And we took the reading of the mass again. Notice what's on the balance when we write this number down. Okay, now we put the Alka Seltzer in the vinegar and we let it completely react. Wait till all the bubbles are gone and then record the mass again. All right, now I'm going to ask you to think, what are you going to do with that data? How is that going to help you? You have the mass of the tablet. Pause the tape here and see if you can figure out what you're going to do next. Come back when you've got some ideas. Okay, so the mass of the tablet, the cup, and the vinegar before the reaction was 42.4 grams. The mass of the cup and the mixture after the reaction was only 41.2. So what is the difference in mass? What is it, and where did it go? Well, if you said the carbon dioxide, you're correct, because that's the bubbles that came out of the reaction. So now we can find the mass of the carbon dioxide. Now we've got a foothold into this problem. So once you know that, the mass of the carbon dioxide, to subtract 42.4 minus 41.8 is 0.6 grams, then we can calculate using our brilliant stoichiometric skills. We could calculate the mass of anything here. But what we're interested in is the sodium hydrogen carbonate. So that becomes a simple stoichiometry problem. So we're asked to find how many grams of the bicarbonate are present when 0.6 grams of carbon dioxide are released. So this is a mass-to-mass problem. So we're interested in this part of the stoichiometric equations, the mass of the known, which we know from our little experiment, times 1 over its molar mass, times your molar ratio, which we'll get that from the balanced chemical equation, times the molar mass of the chemical we're looking for, that's the sodium hydrogen carbonate, and that'll give us the mass that we're trying to find. All right, so our plan would be to take the mass of the carbon dioxide, convert it to moles of carbon dioxide, convert that to moles of sodium hydrogen carbonate, and then use the molar mass of sodium hydrogen carbonate to convert it to the mass of the sodium hydrogen carbonate. All right, so go for it. See if you can figure this out. Pause the tape, come back when you're ready. All right, so our 0.6 grams of CO2, our first conversion factor wants to cancel those grams of CO2, so they're in the denominator. And we have moles of CO2 up top. That's how we'll convert to moles. So you need a periodic table and a calculator. You add 1 carbon and 2 oxygens together, you get 44. The next step, now that we've converted to moles of CO2, is to use a mole ratio. We want the moles of CO2 to cancel and the moles of the bicarbonate to appear. So you look at your balanced chemical equation. In front of the sodium hydrogen carbonate here, there's nothing. That's understood to be a 1. This question mark goes with the question, not the equation. And the CO2 is also 1. So your mole ratio is 1 to 1. The last step is to cancel now those moles of sodium hydrogen carbonate. So our conversion factor would have that chemical in the bottom, the moles of that chemical, and the grams of the bicarbonate up top. So now we need to find the mass of 1 mole of sodium hydrogen carbonate. So we find a periodic table and add 1 sodium and 1 hydrogen and 1 carbon and 3 oxygens together, and we get 84 grams of NaHCO3 over 1 mole of NaHCO3. All right, so make sure those units cancel. Your grams of carbon dioxide cancel here and here. Your moles of CO2 cancel here and here. Your moles of sodium hydrogen carbonate cancel here and here. And the grams don't cancel. All right, so do the math. Come back when you're ready if you haven't done the math already. All right, the answer is 1.145 grams. Not exactly what they said it was going to be, is it? Okay. Or in milligrams, since the box is in milligrams, we need to make that conversion to milligrams, 1,145 milligrams. And they said it was 1,916 milligrams. Okay. Now, before you run off and start a class action suit and have everybody who ever took Alka Seltzer sue, I would repeat this experiment many, many times with much better equipment than we have in our school laboratories. Okay. All right, so here's some extra problems to practice at stoichiometry. For the reaction represented by this equation below, how many grams of sodium hydrogen carbonate are present in the tablet of Alka Seltzer if 88 grams of carbon dioxide are released? All right, so it's a mass-to-mass problem, so you're interested in that middle part of the stoichiometric equations. In order to find the grams of sodium hydrogen carbonate from 88 grams of CO2, you multiply by 1 over the molar mass of CO2. So if you take 1 carbon and 2 oxygens, and your molar mass is 44. Then you use a mole ratio with CO2 in the bottom and sodium hydrogen carbonate up top. Your mole ratio is 1 to 1. And then finally, you use the molar mass of the bicarbonate, the number of grams over moles. Make sure those units cancel. Grams of CO2 cancel here and here. Moles of here and here. Moles of CO2 cancel here and here. Moles of the bicarbonate cancel here and here, leaving us with grams of the bicarbonate. So the answer is 168 grams. All right, here's another problem. Do this on your own. Practice it. Come back when you think you have an answer, and we'll go through it. Okay, it's a mass-to-mass problem again. To find our grams of sodium hydrogen carbonate from 22 grams of carbon dioxide, your first conversion factor is the 1 mole of carbon dioxide over its molar mass, which is 44. Second conversion factor is a mole ratio that cancels the carbon dioxide and produces the sodium hydrogen carbonate. You get these numbers from the balanced chemical equation in front of the bicarbonate and in front of the CO2. They're both 1. And then you multiply by the molar mass of the sodium hydrogen carbonate, which is 84 over 1 mole. Make sure those units cancel. The grams of CO2 cancel here and here. The moles of CO2 cancel here and here. The moles of bicarbonate here and here, leaving you with grams. All right, so hopefully you've done the math right. Answer on 3. 1, 2, 3. 42 grams. If you got that, pat yourself on the back. You are brilliant. If you didn't, then practice again. You will be brilliant. All right, here's another practice. So go for it. Come back when you're ready. Okay, mass-to-mass problem. In order to find the grams of sodium hydrogen carbonate, you start with 132 grams of carbon dioxide. Your mole ratio, your first conversion factor is the ratio of moles, 1 mole of CO2 to the molar mass of CO2, which is 1 over 44. Then you use your mole ratio with the moles of sodium hydrogen carbonate over the moles of carbon dioxide. And then finally you multiply by the molar mass of a sodium hydrogen carbonate. Make sure those units cancel. Then do the math. 252 grams. All right. Here's another practice. Have at it. Come back when you're ready. Okay. All right. So to convert to 220 grams, you multiply by 1 mole of CO2 over the molar mass of 44 for CO2. Then you multiply by a mole ratio with CO2 in the denominator and the bicarbonate in the numerator. That's 1 to 1 from the balanced chemical equation. The last step is to multiply by the molar mass of the sodium hydrogen carbonate over 1 mole. Double check those units, then do the math. 420 grams of NaHCO. That's a typo. Should be NaHCO3 here. All right. Make note of that. That's a typo. Okay. All right. So here's a quiz. Have at it. If I didn't tell you otherwise, just do this on a piece of paper. If I give you another website to do it on, then you could use that. You just check the syllabus. If you don't know, just do it on a piece of paper. Then probably that's the best way. Okay, so come back when you're ready. Okay, so here you convert your 176 grams of carbon dioxide by multiplying by 1 mole of CO2 over 44 grams. And then your mole ratio is the bicarbonate over the carbon dioxide, 1 to 1. And the last step is to multiply by the molar mass of the sodium hydrogen carbonate over 1 mole. And got to fix that mistake. It's NaHCO3, 336 grams of NaHCO3. Okay, that brings us to the end of our virtual Alka Seltzer Lab.